Hello! The project we worked on this semester is called GOGO Tennis, a fitness-based multiplayer tennis game for users to play with their friends and family.
After brainstorming with the team, there were multiple problems we decided that we wanted to address. The first one being that it can be difficult for people to find the energy and time to leave their house to socialize, especially after a long day of school or work. There should be more options to help users socialize without needing to spend time and energy commuting to do activities outside their homes. Another problem that we found was that exercising in public can be nerve-wracking for many people, but exercising at home alone can also be boring and discouraging, as we found that there are limited options of engaging and interactive exercises that can be done in the safe confines of one's home. Lastly, while there are existing applications that promote spending time with loved ones through activities that require some movement or exercise, they usually were not free and required the purchase of a separate console, making these applications inaccessible to most people. To solve the problems we wanted to address, we decided to build a fitness application that encourages people to stay active through fun games and interactions. We wanted to make sure that our application would be accessible without the need for users to purchase separate consoles. Thus, users will only need a mobile device and a separate laptop or desktop screen in order to use our application. So users will be able to perform physical activities within the comfort of their own homes with devices they already own.
So we have two primary personas for our tennis app. One is a 9 to 5 office worker, and the other is a college student. These kind of have a bit of overlap where they're sitting all day working or studying, and then after a long day of work, they come back home and they want to stay active, but it's too far to go to a tennis court or they don't have the energy. They can just pull out the app and start playing on their phone. This works with families. Take out your phone, play with your kids, and college friends as well. Just hit up a friend at a party or something and say, "Hey, you wanna play tennis?" So for our actual gameplay, it's gonna be tennis, obviously, but we're gonna be controlling our tennis racket with your motion controls from your phone. We'll show you more of this in the demo, but that's very easy to pick up and learn, but also has a lot of skill and depth involved. And our goal is to make this a multiplayer game where each phone has a client and the host is a web server, so you can link up with anyone you want.
Initially, our team had opted to move forward with a largely Arctic concept and a neon color palette as the theme of our tennis game application. However, the resulting concept art drafts did not align with the feel of the game that we had ultimately visualized, which was an energetic, dynamic, and vibrant game to encourage users to keep moving. The largely Arctic theme had caused the game to feel more calm and restful. Due to this, we had to go back to the drawing board and create more drafts with different concepts. Eventually, we had decided to progress with an Arctic cyberspace fusion concept to both bring an energetic feel to our application as well as stay true to our initial vision.
Here's a demo of our project.
When our application is first launched, all users will be brought to the home screen, whether it is the desktop or mobile version. Here, the users have three options: to launch a server, join a game, or change their game settings. In the settings menu, users can adjust the volume of the sound effects or the background music. Pressing on the return button will return them to the main menu. Once all of the settings have been adjusted to the user's liking, it is now time to start a match. By clicking the server button on their computer, the user will open up a local room on their Wi-Fi that their friends can join on. As mentioned before, both users have to launch their app on their phone and click join to enter and start the game. When a client clicks the join button to enter the room on their phone, they will land on the character selection screen. You can see that we joined as player 0. The two options here are the polar bear and penguin. Let's choose the polar bear. You can see that my changes are synced between the client and server screens. Player 1 has also now just joined as a penguin. In order to start the game, both players must lock in their character selections to show that they are ready. Now, all players have spawned into the tennis field and are ready to play the game.
Players must win the best of 3 rounds in order to win the game. In order to score a point, the opponent must miss the ball or hit it out of bounds. Our scoring system reflects real tennis game scoring, and we have included game states such as deuce and match point. In order to stand out from competitors like Wii Sports, we opted for more realism, and this basically means accurate physics simulations, the ability to control racket orientation, and different hit strengths depending on swing speeds. On the physics side, we noticed that sometimes the ball would go through the racket in Wii Sports and still count as a hit. So, in our game, we actually calculate the angle and speed the ball would bounce off the racket at. Additionally, between rounds, we play round animations to signal the restart of the scoreboard, and the according winning and losing emote will be played on the specific player. To make the ball more visible on the computer screen, we added an imprint on the ground, so whenever and wherever the ball hits the ground, a red circle will appear to show its last location. Additionally, we added a trail renderer to the ball to always make sure its location in the air is obvious. Lastly, the player serving always has an indicated server tag, and an according out tag will be played on the field if the ball is out. Between every play, the winning player will have a sparkle animation play over their head, and the losing one will have a confused star animation play over their head. At the end of the game, on all devices, the respective winning player will show up with a victory screen, and through the computer, can users select to play a rematch or quit the game. Now, please enjoy a no-talking version and a sped-up version of the last half of the game with the features I just mentioned. Now, here are 2 office workers playing tennis after a long day of work. Because of its accessibility, they can easily set up a match and play in their home together. To serve the ball, the user has to swing up and then swing forward to hit the ball. We also let the player determine how hard they hit the ball by changing their swing speed. A gentle shake of the phone won't make the ball go far, while a fast move will launch the ball at impressive speeds. We use readings from the phone's accelerometer to do this after they are processed to be unbiased from the influence of gravity. As mentioned before, the racket orientation does matter, and players can take advantage of our more in-depth physics by allowing them to directly control the orientation of the racket and, consequently, the direction of the ball after a hit. This is done by using the phone's gyroscope sensors and comparing the relative change after each frame. These new degrees of freedom introduce a high skill ceiling, and the game might become unfun or impossible for new players. To account for this, we decrease the gravity in our game to make the ball slower and give players more time to react. We also added an aimbot that would help guide the ball to the correct place even if the racket isn't orientated in the right direction to result in a good hit. Now, all players can have fun, de-stress, and do something that gets them on their feet.
For front-end and back-end, we used Unity Engine as it can help us render our 3D objects well. Unity uses object-oriented programming to allow developers to build systems. So, to get everything to work, we wrote different contained classes like player, score system, ball handler, racket, that worked in parallel with each other. For our multiplayer architecture, we used Unity netcode, Unity's official multiplayer library, to build out our multiplayer system. They have high-level functions called client RPC and server RPC that allows clients to send messages to the server and vice versa, so we can sync game data across devices. Thus, while building, we built with server authority. For our 3D models, we were able to build all of our assets in Blender. We utilized UV mapping to accurately texture our models, and we used an online tool called Mixamo to rig and animate our character models. For testing and debugging, we used a Unity editor, Unity remote, and made builds using Xcode to our phones. To test our tennis game, we tested various different scenarios, such as hitting out of bounds, double bouncing, scoring a point, all to confirm our scoring system was functional and reflected real tennis. After ensuring our game worked in single-player mode by programming an opponent bot, we moved on to testing multiplayer. In order to test our server and client builds, we needed to run our game on multiple devices to make our game sync correctly across clients. We also needed to test on both Android and iOS devices to make sure the game behaved the same way. By using debug statements, we were able to do unit testing and integration testing, both in Unity and Xcode, to check computer server builds and phone client builds. We closely examined our console logs to find issues with our code and quickly resolved them.
Throughout this project, we faced many challenges, both technical and non-technical. From a technical standpoint, we found it challenging to design a system architecture that would meet the functional needs of our project. We had to think about the different components of our project and required languages, libraries, frameworks, and how they would be integrated. Given the uncommon use case of our project, we found it difficult finding updated guides online that would be suitable for the implementation of our project. Many times, we found libraries and solutions that were deprecated and did not work as seamlessly with the rest of our project as we had hoped they would. Balancing the aimbot was difficult from a design and technical perspective. We wanted our game to be easy to pick up, but more complicated than just swinging your phone at the right time. At first, the aimbot was hard-coded to place the ball in certain positions, but we later changed it to correct the player's aim. This also allowed us to adjust how much help the player would get to adapt to players of different skill levels. We also struggled with the hardware limitations of gyroscopes. Namely, the gyroscope would drift, causing the racket to slowly move even when the phone is stationary. We fixed this by only moving the racket if a certain threshold of motion was detected. In addition, some gyroscopes were biased, so the phone's orientation would be slightly offset from the racket's orientation at all times. As for non-technical challenges, we had to learn how to balance the complexity of the project based on the experience that our team members had. Namely, our project is heavily Unity-based and requires familiarity with the code principles and mechanics of Unity. While most of our members were proficient with Unity, we had to establish a decent learning curve for our team members who had little to no experience with Unity. Aside from that, aesthetics were also an aspect of our project that was a challenge for us. It took us some time to discuss and establish the desired aesthetic of our project that would hopefully appeal to a wider range of our target audience.